This is a proof of concept video of how powerful the scaffold method is when used to analyze the units. This is also called the factor label method or dimensional analysis. We're going to look at formulas that involve circle and sphere and just talk about the units, how the units multiply out to be the unit we formerly known as a distance, an area, or a volume. Okay? For the perimeter of a circle, we can use the term pi d, represents the perimeter or circumference of a circle right there. D is meant to represent the diameter, two radii stuck together. This length here could be measured by anything. It could be, this length here could be measured in feet, inches, miles. We're just going to keep it in meters. So this formula here, when plugged into a scaffold, pi is just a number, doesn't have any units to it. D is a number that has the unit meters. In this little baby scaffold here, the perimeter or circumference of a circle is only in the unit of meters, which makes sense. It's just a length. The area of a circle. Now an area has to be the length times the width, or meters squared. We agree on that. The area of anything, circle, square, octagon, has to end up being in meters squared. For a circle, we say the area, pi r squared. Plugged into the scaffold, we can expand this out. Instead of saying r squared, we can say r. Pi doesn't have a unit, so we won't put a unit in here. The radius is going to be measured in meters, and the radius is going to be measured in meters. No units cancel. So this side of the equation ends up being meters squared. Again, a unit we recognize to be an area, whether it's a circle, a square, or whatever. The volume, the volume of a sphere is 4/3 pi r cubed. And again, a volume is going to be meters cubed. The volume of anything, whether it's a die, box, your Amazon boxes, or any shape, is going to have a volume of meters cubed. When we plug this thing into our scaffold, 4/3 is just a number. It doesn't have any units to it, so I'm just going to leave that blank. Pi doesn't have a unit to it as well, so I'm just going to leave that blank. Radius cubed is the same thing as meters times meters times meters, because something to the cubed is times times times. That, no units cancel out because there's no units in the denominator. That just equals meters cubed. Each of these formulas, when the units are broken down, explicitly tell you or explicitly end up being the units we recognize. This is meant to show how the scaffold shows you the units of the formulas. Thank you.